Assalamu alaikum students, hope you are doing well. It's me, Sir Ramzan. Okay, today we are going to discuss the image formation through lenses. Before going into detail, we should know like there are two type of lenses. Number one is on the screen right now. This is called converging lens. In a type of converging lens, the light rays actually converge at a point which is named as a focal point. So this focal point is a point where all the light rays would focus. So this is actually a thin converging lens which is displayed in the blue color. So the light rays parallel to the principal axis. The black dotted line is called a principal axis. The principal axis is an imaginary line which passes through this centered position. This center is actually called optical center. So the light rays which are parallel to the principal axis would pass through the focal all the time. So let's proceed. Like for example, this is a converging lens. So these light rays would go this way and they would all pass through a single point. This single point is named as a focal point. So focal point is a point where all these light rays would actually focus. This is called a focal point. This is called optical center and it is denoted by letter O. So when we are going to deal with these type of things, we should remember one thing which is called a focal length. So focal length is the distance between the optical center, which is denoted by letter O, and focal point, where all these light rays would focus. So this was about the convex lens. This is a convex lens. This is also named as a converging lens. Now let's talk about a concave lens. Concave lens is also named as a diverging lens. So if you see this type of lens, so there are two type of focal points given. So the because the uh, lens is actually a transparent medium, so light rays can come from either side. So let's talk about it. Like for example, the light rays which are parallel to the principal axis, they're not going through this focal point. Now the reason, because this is not a converging lens, this is actually a diverging lens. So if the light rays are not going this way, so how they would look like, or how they would go, like they would go like this way. But at which angle they should go, from here, here, or which angle? So we have to adjust it in such a way, like this light ray should pass through the focal behind the lens, like from where the light rays were coming, I have to let the light pass through that focal point. So this is how the light ray would look like. Similarly, there would be one more ray which is passing through the other point, the next through here. We have to construct all these light rays using the meter rule, and the last one, which is here, I have to pass this ray through the focal point at the back. Now we should remember this thing very important over here, and this is actually the focal point, and because the light rays are going backwards, that's why it is considered to be the virtual one. So virtual rays seems to be going back. Actually they are not going back, but we have to show, like if they were extended, they would have been passing through the focal point at the back. So this is how these light rays would actually look like when they are passing through a concave lens. Hope this thing is clear. Now let's proceed ahead and talk about some important facts. For example, we have four important cases for the case of the converging. So when the light ray which is passing through the optical center, like this is passing through the optical center, it will never bend. So it would go straight. So rather it is going horizontally, or for example it is coming to at certain angle, it will never bend, it would go straight. The ray which is parallel to the principal axis, it would pass through the focal. The ray which is passing through the focal and striking the lens, the emergent ray which is coming out of the lens, would be parallel to the principal axis. So case number 3 and case number 4 are actually converse of each other, like they are opposite to each other. Now, on the basis of this information, I have to proceed to multiple cases. So in this particular situation when we have to draw the ray diagrams. So we have multiple cases. In case number one, the object is displayed here with the red arrow that is placed at a distance less than the focal length. In the other case, the object is placed at the focal length, like at f. In the third case, it is between f and 2f. In fourth case, it is exactly at 2f. At fifth, it is beyond 2f. And at sixth, it is at somewhere at infinity. And seventh one is basically the concave one. So let's start discussing from case number one. So in the case number one, whenever we have to draw the ray diagram, so we should take care, like there must be two rays, one which is parallel to the principal axis. We have to take it straight horizontally till the middle of the lens, and it would pass through the focal. And the ray which is passing through the optical center, it would go undeviatedly. These are the out of the four things that we have read earlier. So because these light rays are not meeting on the opposite side of the lens, opposite side of the from where the light rays were coming, so we have to extend these light rays in such a way, like we have to see like at where they are actually meeting. So if we see, like, because the light rays are meeting at the back of the lens, so that's why, as the way we have talked, like we have to extend these rays, and that is why it is called a virtual image. So whenever the light rays are meeting in such a way, like it is on the same side of the object, that is why the image is named as a virtual image. So this was the object, and this is actually the image formed. What would be the properties of the image formed here? So this image is virtual image. So virtual image is the one which can't be captured on screen, which cannot be captured on screen. So the object seems to be there, but actually it's not. So if the image is virtual, whenever the image is virtual, it would always be upright as well. So it's a pair. So the image which is upright, it is always virtual. If we see the object size is smaller, the image size is bigger, so we can say like image is magnified as well. It's the bigger in size, and it is actually used in magnifying glass. So this is case number one, which is very important for the paper point of view. Now we will proceed to case number two. Case number two is very important. Now there are two rays. The ray which is parallel to the principal axis must pass through focal, and the other which is passing through the optical center is going undeviatedly. If we follow the passages of these rays, these are not going to meet ahead. So I'll try to extend these rays at the back. So if I just try to extend them, they are not going to meet either on the left side, which means like if the image would have formed, it would have formed at somewhere infinity. So the image formed is actually the virtual image. Virtual is always upright. The image is at infinity, and it is used in spotlights. So this is case number two. Let's proceed to case number three. Now the object is placed between f and 2f. I have two rays. The ray which is parallel to the principal axis is passing through the focal, and the ray which is passing through the optical center would go straight. If we see, these rays are going to meet somewhere here. So I have to draw an arrow. So I have to draw an arrow in such a way, like it should exactly be starting from the principal axis. So if I just look for the properties, the image is real now because it's upside down. So real is always inverted. Inverted means like it is upside down. So let's suppose if this is the object, so inverted means like it would be upside down. So the upside down image is called, this is the upright, and this is inverted. This is inverted. Inverted means upside down. So the image over here is real, inverted, and if you see, the size of the image is very big. So the image is enlarged or magnified, and it is used in multimedia projectors. In the schools, we usually see them. Case number 4. Now the object is placed exactly at 2f. So the ray which is parallel to the principal axis would pass through focal. The ray which is passing through the optical center would go straight undeviatedly. The ray the rays wherever they meet actually is the point where the image is formed or image is casted. So this is the image. So the image properties are: the image is real. Whenever the image is real, it would always be inverted, and this is the same size as of object, so the image has same size, and it is used in photocopy machines. The size of page you are giving to the photocopier, he is going to make an image of it. We can electronically make it bigger or small, but for a simple case we can consider it like it is used in a photocopy machine in order to make the same size photocopy as the size of the paper we have provided to the photocopier. Now the case number 5. Now object is beyond 2f. So there must be again two rays. One ray which is parallel to the principal axis. The ray parallel to the principal axis would always pass through the focal, and the other ray would be this way. Remember one thing, we have to take these rays always from the top, like from the top of the object, from the starting from the tip. So if I just make it a bit proper again, okay, over here the image is to be formed. So the image is formed here. So the image is real, inverted. Because it is smaller in size, the smaller is named as diminished. Diminished means small, and it is used in human eye or camera. We usually see the things, they are upright. The image formed on the retina is not upright, it is actually upside down. But our brain reads it in such a way, like the objects which are actually inverted on the retina, they seems to be upright in reality. Now let's move to case number 6. So I have to reiterate this, and I'm going to make it once again in order to make it a bit difficult situation for you. So for example, if the object is somewhere here, it's a bit technical and tricky question. For example, the object is somewhere here. Now the problem here is uh, like if there are two rays, the one ray is passing through the optical center, would pass through straight, but the ray which is parallel to the principal axis is not able to pass through the lens, and the reason is because the lens is not that much of height. So how what we are going to do, we are going to let it pass through the focal first, and the ray which is parallel to, which is passing through the focal, emergent ray would be parallel to the principal axis, and if you see, the size of the object would be formed, image would be formed here. So the image properties are: image is real, image is inverted, image is smaller in size, smaller means diminished, and it is used in telescopes. So this is how the image is formed. So you would see like this object is, and this image is of equal size, so they are not actually, because we are going to make uh, a very distant object to be visually in front of us in order to make it magnify. So we are going to make it a bit bigger. So the image formed is actually uh, bigger, but actually smaller than the size of the object. For example, a distant planet, we cannot form that much size of the image, the size of the planet. That's why we are going to make it considered to be a smaller image. Now in the case number 7, we have a concave lens. So we are going to, wherever we are going to make the object placement, the properties would be same, like image would always be virtual, where whenever the image is virtual it is upright as well. Image is always diminished, and it is used in eye lenses, like the glasses we usually make, we usually use in order to see, like obstacles, opticals. Okay, so wherever we are going to place the object, so let's suppose if I'm going to place the object somewhere here between f and 2f, so there must be two rays again, one ray passing through the focal and the other which is parallel to the principal axis. Now it cannot go through here because it is not a converging lens, it is a diverging lens. I have to make it this way, like if I'm going to make it this way, so I have to let the light ray pass through the focal at the back over here. So this way. So these light rays are going to meet and the image is formed here. So you can tell like the image is virtual. Virtual is always upright. It is the diminished one, and this is easy to see. Whenever examiner asks you like where would you put your eye in order to see this image, so you are going to put your eye here. So in all these cases, wherever you have to see the image, you have to put your eye at the back of the lens. Like for example, if the object is on one side of the lens, on the left of the lens, the object is there, then you have to put your eye on the other side of the lens. So let's suppose this is the lens or this is the lens. In both situations, you have to put your eye on the opposite side of the lens. So that is all for today. Hope the topic is clear to you. Share it with your friends. Take care and Allah Hafiz.